Hello, and welcome to today's video where we'll be exploring the fascinating history of computing and the different numbering systems used in modern technology. We'll cover key milestones in computing, look at some early devices, and learn how to convert between different number systems. Let's get started. Let's begin with one of the earliest known counting devices, the abacus, dating back to around 3000 BCE. Ancient civilizations like the Sumerians, Egyptians, and Chinese used this simple yet powerful tool for basic arithmetic operations. Moving forward in time, we have Napier's bones from 1617, a device using rods to perform multiplication and division. Then, in 1642, Blaise Pascal developed the Pascaline, an early mechanical calculator to help his father, a tax collector. Another notable invention was Leibniz's step reckoner in 1673, which could perform all four arithmetic operations: addition, subtraction, multiplication, and division. Next, in 1837, we enter the age of analytical engines. Charles Babbage designed the first concept of a general-purpose computer, which included elements like memory and control flow. Although it was never fully built during his lifetime, Ada Lovelace in 1843 became the first computer programmer by writing algorithms for this machine, envisioning its potential beyond simple calculations. Fast forward to the late 19th and early 20th centuries, we see the rise of electromechanical and early digital computers. Hollerith's tabulating machine from 1890 used punched cards to process data for the US Census. Konrad Zus's Z3 in 1941 became the first programmable electromechanical computer, and in 1945, ENIAC was one of the first fully electronic digital computers, used for military calculations during World War II. The path to modern computing began with the invention of the transistor in 1947, which revolutionized computing by making computers smaller and more efficient. Then came integrated circuits in 1958, and the first microprocessor, the Intel 4004 in 1971, which packed a CPU onto a single chip. By the 1970s, computing reached homes and offices. The Altair 8800, introduced in 1975, sparked interest among hobbyists and led to the creation of Microsoft. The Apple II, released in 1977, helped popularize home computing, and the IBM PC, launched in 1981, set the standard for desktop computers. Concrete devices played a crucial role in computing. The abacus was an ancient counting device used for basic arithmetic. The slide rule was an analog device for multiplication, division, and complex functions. Punched cards, introduced by Hermann Hollerith in 1890, were a data input and storage system. Teletypes connected to early computers were used for input and output before the era of screens. Now let's switch gears and talk about numbering systems. In computing, we use various systems to represent numbers. The most common ones are decimal, which is base 10, uses digits 0 through 9. Binary or base 2 uses digits 0 and 1. Octal, which is base 8, uses digits 0 through 7. Hexadecimal or base 16 uses digits 0 through 9 and A through F, where A equals 10, B equals 11, and so on. Let's go through a few examples to understand how we convert between different numbering systems. Decimal to binary. To convert decimal 13 to binary, divide by 2 and record the remainders. Reading from bottom to top, 13 becomes 1101 in binary. Binary to decimal. Convert binary 1101 to decimal by multiplying each bit by powers of 2 and summing the results. 8 plus 4 plus 0 plus 1 equals 13 in decimal. Decimal to octal. Convert decimal 65 to octal by dividing by 8. The result is 101 in octal. Decimal to hexadecimal. To convert decimal 255 to hexadecimal, divide by 16. The result is FF in hexadecimal. And that's a brief look at the history of computing and how different numbering systems work. We've gone from ancient tools like the abacus to modern computers that rely on binary, octal, and hexadecimal systems to process data. If you found this video helpful, make sure to like and subscribe for more content like this. Thanks for watching.